Let's take a look at two examples that highlight the importance of understanding mathematical notation, and in particular that importance in relationship to finding the derivative of a function. So our first function here on the left is f of x equals sine to the fourth power of x, and our second function here on the right is sine of x to the fourth power. The significance here is what is being raised to the fourth power. So when we look at this function on the left, f of x sine equals sine to the fourth power, this is communicating that we are taking the sine of x function and raising it to the fourth power, which has implications for finding the derivative in terms of the chain rule and what that outer function is and what the argument to that function is. Similarly, when we see sine of x to the fourth power, that means we're taking the sine function and evaluating it at x to the fourth power. Again, significant implications in terms of the chain rule when we find a derivative. So let's go ahead and find the derivatives of these two functions. So in looking at our function on the left, f prime of x is going to be, so the argument to the function, or the inner function, is this sine function. So what we want to focus on in terms of finding our derivative here is that we first need to know what that outer function is. Our outer function is this raising to the fourth power. So when we evaluate our derivative, we're going to be using the power rule, and so we'll have 4 times something raised to the third power. Now, recall that with the chain rule, when you take the derivative of that outer function, you leave the argument alone. That is, we don't want to change the sign of x. We keep that argument when we take the derivative of the outer function. Now, though, once we've done that, derivative of the outer function, leaving the argument alone, we then take the derivative of the argument. And I'm not going to go ahead and write that just yet. I'm going to write that as a derivative of sine of x. At this point, we can go ahead and rewrite this as 4 times sine cubed of x times, now the derivative of sine of x is cosine of x. And so the derivative of our function is 4 times sine cubed x times cosine of x. Now, focusing our attention on the function on the right, again, keeping track of what the argument of the function is. The argument is this x to the fourth. And the outer function is this sine function. So when we go to find our derivative using the chain rule, f prime of x is going to give us what is the derivative of that outer function. The derivative of sine is cosine. So we're going to have cosine of something. Now remember, when you take the derivative with the chain rule, you leave the argument of the function you're working with alone when you take the derivative of the outer function. So derivative of sine was cosine, and we leave the argument of that sine function alone. Then we multiply by the derivative of that argument. And the derivative of that argument would be the derivative of x to the fourth power. So f prime of x is going to be cosine of x to the 4th power times 4x cubed, applying the power rule to this x to the 4th function. So in the end, our derivative, our f prime of x, is 4x cubed cosine of x to the 4th power. Now notice that the two derivatives are significantly different. So the location of that exponent, or what you are actually raising to a power, is very important, and paying attention to that and understanding what the mathematical notation is trying to communicate will help you be successful. I hope this helps.